Hello, this is Mr. Miller, and welcome to video 11b. In this video, we're going to talk about the standard form for lines. It's a form of an equation for a line. There are several different patterns for lines, and this is the first one we're going to consider. Basically, an equation in standard form looks like what we have here. It's a number times x plus another number times y equals to a third number. A, B, and C represent numbers. X and Y are variables. So we're going to take a look and see if we can recognize equations that are in this form. And then we'll take a look at the graphs of all of these and see that which ones are lines or not. So one of the benefits of standard form is every equation for a line can be put in standard form. All right, so here we go. It says circle the equations that are in standard form and cross out the ones that are not. So when we look at this first equation, we have 2. That's just a number times x plus a number times y equals to 6, a third number. This is in the pattern of standard form. Ax, where a is just a number, plus by, where b is just a number, equal to c. So we have a equals 2, b equals 3, and c equals 6. This one is an equation in standard form. If we graph it, we're going to see a line. All right, this one is not. We can't have any exponent other than 1. So if there's any x squareds, x cubes, get rid of it. That's not a line. All right, look at this one. We have a number times x. B can be negative. So we have a negative number times y. We can think of it that way, equals a third number. So in this one, a equals 4, b equals negative 3, and c equals 12. That is an equation for a line. That's an equation in standard form. This one has an absolute value. No absolute values. Cross that one out. This one, the variables are being multiplied. Can't have that. It's just a number times x plus a number times y equals a number. Can't have that either. Oh, this one has x squared and y squared. Forget about it. All right, this one has a number times x and a number times y equal to a third number. So we could say this one, a is 1/2, b equals negative 6, and c equals 8. Well, let's say this is in standard form. Now, some authors of math books would tell you that a and b and c need to be whole numbers or integers. They can be positive or negative numbers, but no fractions and decimals. But for our purpose, we're interested in whether it's an equation of a line or not. We're going to let a, b, and c be any number, okay, for us, and we'll be fine. All right, this one actually is an equation for a line, but it's not in standard form. It's because in standard form, the x and y are on the same side. But we could write it in standard form. We could start with this equation and add 2x on both sides. And over here we'd have 2x plus y. We can't really combine those. But over here, minus 2x plus 2x is 0. We're left with 4, and this would be in standard form. So technically, this one is not in standard form, but it is a line, and it can be written in standard form. Okay, I've opened up a graph in Desmos, and I'm going to graph all the equations we just discussed. The first one we said was in standard form. A number times x plus a number times y equals 6, and when I click on the graph, sure enough, it's a line. So if an equation can be written in standard form, we know the graph is going to be a line. All right, the next one we rejected because it had an x squared in it, and we see it's not a line. That's actually a quadratic function, and something we'll study in sophomore year. All right, this next one we said was in standard form. A is 4, b is negative 3, and c is 12, and there you see it. It's a line. We got rid of the next one because it's an absolute value, and a good thing we did. It's kind of bent into a V shape. That's not a line. We got rid of this one also because we're multiplying x and y. All right, that's not a line. That's not in standard form. Got rid of this one because of the x squared and the y squared. And we see this gives us a circle, not a line. This one we kept, and a good thing we did, see, it's a line. So if we can write an equation in standard form, we know the graph is going to be a line. This last one was not in standard form, but we wrote it in standard form, and sure enough, it's a beautiful line. Okay, we're going to move on to our next example here. In this problem, we're given an equation in standard form. Here it is. And we'd expect the graph of that to be a line. Our job is to figure out which points are solutions to this equation. Like when we put the first coordinate in for x and the second coordinate in for y, does it make the equation true? So we're going to find the ones that satisfy it, and then we're going to plot those. Okay, so for this first one, we put 5 in for x, so we'd have 5 minus 2 times y minus 2 times 2. 5 minus 2 times 2 equals 1, which is what the equation says it should be. So this point works, and we're going to graph it. 5, 2 would be right there. All right, let's try 2, 3. We'll put 2 in for x and 3 in for y. So 2 minus 2 times 3 is 2 minus 6 is negative 4. But according to the equation, it's supposed to be 1. So we're going to cross that one out. That one doesn't work. Let's try 1, 3. 1 minus 2 times 3 is negative 5. No, it's supposed to equal 1. That one's bad. Let's put 3 in for x and 1 in for y. 3 minus 2 times 1 is 3 minus 2, which is 1. So this one works. 3, 1 is right there. 4, negative 1. When x is 4 minus 2 times negative 1, that's actually 6, which doesn't work. It's supposed to be 1. Let's try 1, 0. Put 1 in for x minus 2 times 0. That's 1 minus 0, which is 1. That one works. So 1, 0 is right here. Negative 3, negative 2. Negative 3 for x minus 2 times negative 2 is negative 3 plus 4, which is 1. Yep, it's supposed to equal 1. That one works. So negative 3, negative 2 is right there. And finally, negative 2, 4. Negative 2 minus 2 times 4 is negative 10, which doesn't work. So of these, 4 points worked, and sure enough, they lie on a line. Now, those are just 4 points. We could find many more. So if I really want to draw the graph for the equation, I would draw a line that goes through these, and I would try hard to put little arrows on it because that line will go on forever. So every point on this line works in the equation, and every point that works in the equation is on the line. All right, so that's an example of checking solutions and graphing them. On this very last example, we want to complete the table. This is a line in standard form again. A is 3, B is 1. If there's no number multiplying y, we can think of it as 1 times y, and C is 9. So when we complete the table and plot these points, they should line up in a line. So we're going to let x equals 1, and our job is to figure out what y is. So 3 times 1 plus y equals 9. 3 times 1 is 3, so we get 3 plus y equals 9. If we subtract 3 on both sides, we get y equals 6. Okay. And next one. This time, for this point, we know the y-coordinate is 5. So we have 3x plus 5 equals 9. We got to solve for x. So we're going to subtract 5 from both sides. We get 3x equals 4. And if we divide by 3, we get x equals 4/3, which is about 1.33. I don't like that one too much, but it is what it is. All right, and then we're going to put 0 in for x. So I need some more room here. When x is 0, we get 3 times 0 plus y equals 9. Well, that's just 0. So we get 0 plus y equals 9, or just y equals 9. And the last one, we're going to put 0 in for y. So the idea is I can give you a value of x or y, and whichever one I give you, we can solve the equation for the other one and find our point. Okay, so when y is 0, we have 3x plus 0 equals 9, or 3x equals 9. If I divide by 3, I get x equals 3. So let's plot these points. 1, 6 would be about right here. 4/3, that's about 1.3, and 5 would be about here. All right, 0, 9 is right here. And 3, 0 is right there. So a little hard to see, but I think once I draw the line through these, it should line up pretty well. Okay, so that would be the graph of this line. So in order to graph a line, we have to find a few points, and we did. And once you plot them, you can use a ruler and draw a line through them. Okay, well, it's time for the journal assignment. So go ahead, find the missing values in the table by using the equation, plot them. They should lie on a straight line for you, and go ahead and graph it. Good luck.